Hello, Astrotometry. I just had some really good questions from Justin on the relationship between the coronal mass ejections and the tropical cyclones. I want to knock them out really quick. And before I do, I want to say that it's really easy for someone who is new at this to get the phenomenon of the coronal hole confused with the phenomenon of the coronal mass ejection. Those are two very different phenomena. They both involve the solar corona. If this is the sun, a coronal hole is an area in the solar corona that appears to be missing. And this area indicates a lower energy form. In other words, there's a missing energy in the higher frequency range that we can see with the extreme UV telescope on the SOHO site and on the Hanode site. And so if you go look at those images, you'll see sometimes that there's a hole or a dark spot in the image where the higher frequency energy is missing. Now in modern solar physics, this is understood to be a place where gases escape from the solar corona and theoretically arrive on the Earth at a certain amount of time afterwards. In other words, we see after the formation of the coronal hole a solar wind. It's what's called in the mainstream solar physics, from this a certain amount of time after the hole opens. And so there's a time variation between the arrival of the solar wind from the coronal hole on the Earth. And the arrival of that solar wind is what I'm associating with the earthquakes. And so the earthquake phenomenon in astrotometry is analyzed very differently, though. And so I don't want to get people confused about the two different ways of looking at it, but at the same time you have to understand both the three-dimensional model and the astrotometric model to understand the phenomenon itself. And so you kind of have to be familiar with both. The other phenomenon, the coronal mass ejection, is when this is the opposite. When there's not a hole here, but it's a very active seething area. It's a very bright spot on the X-ray image of the sun, and this spot wells up and ejects a mass, a coronal mass, and that coronal mass is seen to leave the sun and a lot of times will flow out into space. And theoretically the size of the coronal mass ejection is many times the size of the Earth. But this phenomenon, these two phenomena in astrotometry are understood to be very different than what we are modeling them as three-dimensionally. Our three-dimensional solar physics is replaced in astrotometry by the concept of hypertime. The surface of the sun itself is the axis over which the hydrogen manifestation folds through time on the Earth. When you see a hole here, it represents something that's inside the Earth. It represents something that's under the Earth. And so there's the concept of the earthquake, which is something that happens under the Earth. And when you see something that ejects out this way, it's something that's above the surface in the form of the cyclone. If you analyze that relationship between the above the surface and below the surface as it relates to the solar corona itself, that's another axis in the hypertime analysis. And so you've got this surface of the sun that represents, in a sense, the surface or the atmosphere of the Earth. And when you see things that are up here, they're things that are going to be happening hypersymmetrically with things that are above the surface, and when you see things that seem to be welling down inside, that's something that's going to be related more with an earthquake. And so as far as mapping hypertime, the hypertime mapping between the sun and the Earth, if you're talking about, for example, the coronal hole that was on the sun several days, a week before the Italian earthquake, there was a coronal hole that represents that earthquake and its aftershocks. If you go look at I'm drawing this a little bit high, it wasn't quite that high, but the coronal holes that are up here are tricky, because when you see one that's at this latitude, it's not nearly as large as, for example, the one that you see right now that's near the equator. The equatorial ones are larger because of the effect of the aspect. When you're talking about, for example, if you look at Italy right here, Italy looks fairly small from this aspect. But if you turn the globe towards you, if Italy were on the equator, Italy would look a lot bigger. And so the aspect of the sun itself, and the coronal hole on the sun, is going to have to be taken into consideration if you're interested in doing an earthquake prediction. Now, I gave up the earthquake predicting about 4 or 5 days before the Italian quake. I'm not going to be doing more earthquake predictions for the time being. I'm kind of giving up on that. And one of the earthquake forecasters in Italy actually forecast this event, and he was going around trying to warn people that there was going to be an earthquake, and he was ostracized by his peers. And you know, the government there is still denying the possibility that these types of events can be predicted. Now, his method was very different. He was using detecting the amount of radon gas, which is a radioactive gas that is emitted from the Earth sometimes before these events. Now, in astrotometry, the presence of the radon is completely understandable if you understand the fact that this represents the matter-energy continuity pattern in the Earth. When you see this coronal hole, it has to do with a continuity of the matter and energy on the Earth. And so when you see a disruption, to see a radioactive element increasing in its prevalence in the area, or to see something like an earthquake light or something like that, is an understandable phenomenon, considering that what hypertime is indicating about this is its translation through time itself. And so when the translation of this particular area on the Earth becomes sort of unstable because of an incontinuity in the hypertime wavelength, you could expect something like an increase in the amount of radon gas. It's very telling if you look at how the Italian authorities have responded to this accusation that he deserves an apology for the way he was treated when he tried to forecast this earthquake. If you look at that, if you consider that, I think it's very telling about who these people are actually working for and who they're actually concerned with. I think it's just terrible that we have to bully our public officials or just try to disengage them. Well, I'm going to drop that for now, but gee, gosh, it just makes me so angry. This is the primary reason that I stopped my earthquake forecasting, is because I'm not going to fight with these people. I'm not going to do it. And you know, it seems to me like people are more interested in looking at something like Benjamin Fulford's video on how the HAART project is creating earthquakes, rather than knowing what's actually true. And our governments, our very governments, would rather people believe that was true too, because it makes us seem more ominous. And it just makes me, it pisses me off. It just makes me feel like that these people do not deserve to know when the earthquake is coming. And I know that's a terrible, terrible thing to say, because there's a lot of really, really good people that were probably killed because of this quake that possibly could be still alive today if there was a way to have warned them. But those advances in science are sometimes disallowed by conflicts of interest that run so deep that people aren't even aware of it. And if you look at the issue of the coronal mass ejection, is it always a sun-grazing comet that creates the coronal mass ejection? And I think it's really funny that we can't say solar collider. We can't say that something is colliding with the sun. We have to say a sun-grazing comet. It can't be something that is just headed towards the theoretically largest largest gravitational attractor in our solar system. It can't be that, because it might actually hit it. An astrophysicist might tell you that nothing happens, or that it's not related to some big mass being ejected from the sun. Why would they tell you that? Because this spot, this active region from which it ejects from, is already present a long time before it hits. And it defies our normal three-dimensional analysis of our universe to say that this object that's coming into the sun, that strikes the sun, is ejecting that mass. Why don't we have images from the Soho project of something actually hitting the sun? Well, I think we do. I just don't think that they've been connected with the events that cause them. And so there's this issue of how things move through time as well as space. This object is obviously moving through space. It's also moving through time, but it's moving through time in a way that we have not processed yet. But by looking at it, you can sort this out.